Yeah, the classification of systems. The first one is linear and nonlinear systems, the time variant and time invariant systems, causal and non-causal systems, static and dynamic, stable and unstable, invertible and non-invertible. So, so first one is a linear and non-linear system. How to identify whether the system is linear or non-linear? If the system is represented with input-output relation. Okay, so first linear. Okay, if a system is said to be linear system, it has to satisfy two conditions. One is superposition and second is homogeneity. Okay, so if a system is said to be linear system, it has to satisfy these two conditions: superposition and homogeneity. So what is superposition? Suppose I have a system. I have given input as x1 of x of t, then I got the output y of t. Okay, so this is the input output relation of a system. Okay, suppose I will apply x1 of t initially as the input, then I got y1 of t. Now I will apply x2 of t as the input, I will get a y2 of t as the output for the same system. Now what I do for the same system, I will apply x1 of t plus x2 of t combinedly. Then let us say I will get some y3 of t. Okay, if y3 of t equal to y1 of t plus y2 of t, then the system obeys superposition principle. Okay, next, what is homogeneity? If a system is given like x of t, y of t as the output, as the input output relation. Suppose if I give some alpha times of x of t, let us say some y1 of t, y1 of t is the output. If that y1 of t is some alpha times of y of t, then system obeys homogeneity. Okay, so if a system obeys these two conditions, one is superposition, and homogeneity, then the system is said to be linear system. Okay, so if not, then the system is non-linear system. Okay, so if we want to check the condition of linearity, we have to check these two conditions: superposition and homogeneity. It is the same system. Okay, so what I do in problems, if I have been given a system input output relation, so what I have to do? So system, let us say x of t and y of t. Okay, first I will apply x1 of t, then I get y1 of t. Next I will apply x2 of t and I will get y2 of t. Okay, so to check these conditions, superposition and homogeneity principles. You don't need to check these conditions separately. You can check these conditions combinedly. So I will apply the input as sum a1 x1 of t plus a2 x2 of t as the input. Let us say some y3 of t if y3 of t equal to a1 y1 of t plus a2 y2 of t. Okay, so this condition includes a1 y1 of t plus a2 of t. This condition includes both homogeneity and superposition principles. Okay, so if this condition is satisfied, then the system is said to be linear system. That's it. Okay. Next, second, time variant and time invariant system. So to check whether the system is time variant or time invariant, first let us say the system input output relation is x of t. This is the system, say y of t. Okay, so what I do, suppose for the same system, first I will apply a delay in the system, that is some x of t minus t naught. Okay, if I get some y of output as some y1 of t. Okay, if this y1 of t is y of t minus t naught. Okay, that is, so initially I applied x of t as the input. This is x of t. I got y of t as the output. Then I applied a delay in the input x of t minus t naught. If I get the same delay here to here, the same delay, that is y of t minus t naught, then the system is time invariant. Okay, so if I solve some problems on this, then you will get some clarity. Okay, if not, it is time variant. If y1 of t is not equal to y of t minus t naught, then it is time variant. Next, causal and non-causal systems. Okay, suppose this is the system, x of t is the input, y of t is the output. Okay, if the output y of t, okay, this is the output y of t, depends or otherwise write like this, we can just start. If the present output, the present output depends only on present input or past outputs. So if the present output depends only on the present input or past outputs, then the system is said to be causal. That is, the present output should not depend on future inputs. Okay, it should not depend on future inputs. So in the problems, I will check So whether the system is depending on feature inputs. If it depends on feature input, then it is non-causal system. So if it will not depend on feature inputs, then it is a causal system. I will check these things in solving problems. Okay. Next, fourth one. Static and dynamic systems. So static is also called as memoryless and dynamic is memory. So if the system x of t and y of t, okay, if present output depends only on present input, not on previous inputs or not on previous outputs, okay, it only depends on present input, then the system is static or memoryless. So the present output depends only on present input, okay, so it will not depend on future inputs and it will not depend on past input, okay, then it is memoryless. If present output depends on past output or past inputs for that, then system is said to be memory, this dynamic or memory, okay. So this is the output depends on the previous values, so previous values of input or previous values of output, that means it has some memory, okay, that is dynamic system or memory system. Next, fifth one, stable and astable. This stable and astable is BIBO. BIBO stable, that is bounded input, bounded output stable. I will explain this. Suppose this is the system, x of t as the input, y of t as the output. If x of t is finite, okay, I got some output as y of t. If this y1 of t also finite, then it is the system is BIBO stable. That is, we are giving a bounded input, that is finite input. I am also getting a finite output, that is bounded output. Then the system is said to be bounded input, bounded output stable. Okay, BIBO stable. If I give some finite input, if I get an infinite output, then the system is stable. Okay, we'll discuss in the problems, then I will get clarity. Next, sixth one, invertible and non-invertible. Okay. Suppose this is the system. If I give x of t as the input, y of t as the output. Okay. If I get this x of t from this y of t, I have applied this output to some other system. Okay. Then I got x of t. Okay. If the system is h of t, I will apply this to some h inverse of t. Then I get x of t as output. This is called inverse system. Okay, so inverse system of h of t. Okay, if an inverse system exists for a system h of t, then the system is said to be invertible system. That is, if I apply x of t as the input to the system, I got some y of t as the output. From y of t, is it possible to get x of t? Again, is the input. Okay, so if I want to get x of t as the output, then I have to apply to some inverse system. Okay, so if this inverse system is possible for this x h of t for this system, if I get this h inverse of t, that is, if this inverse system is exist for this system h of t, then the system is said to be invertible system. If not possible, that is, if I cannot get this x of t from y of t from any way, from any means, the inverse system is not possible for h of t for this system. So then the system is said to be non-invertible systems. Okay. When I solve problems, all these things will be cleared. Okay. So these are some classification of systems and definitions. Okay. Yeah. Linear and nonlinear system. I will summarize. Linear and non-linear systems. This is, so for linearity, it has to satisfy two conditions. One is uh, superposition and other is homogeneity. Okay. And for time variant and time invariant, if I apply a time delay in the input, if I get same amount of delay in the output, then the system is said to be time invariant. Otherwise, it is a time variant. And for causal and non-causal systems, so if the present output depends only on present input and past output, then the system is said to be causal. So the present output should not depend on future inputs. If present output depends on future inputs, then the system is said to be non-causal system. And static and dynamic systems, in case of static system, the present output depends only on present input. Okay, not on past input, not on future inputs. Okay, so if the present output depends only on present input, then the system is memoryless or static. For a dynamic system, so if the present output depends on past inputs or past outputs, then the system is called dynamic or memory. In case of stable and astable, this is bounded input, bounded output stable. So if this input is finite and also if I get a finite output, then the system is said to be bounded input, bounded output stable. That is, we are given the input as a bounded input. Then if I get the output as a bounded output, then the system is stable. Otherwise, the system is unstable. And invertible and non-invertible, if an inverse system exists for a system, then the system is said to be invertible. Or if it is possible to get the x of t, the same input x of t from y of t, then the system is said to be invertible. If it is not possible to get x of t from y of t, okay, then the system is non-invertible. Or if an inverse system doesn't exist for a system, then the system is said to be non-invertible system. Okay, so I'll discuss some problems on these things, then you will get some clarity. Okay.